YouTube, in this video we're going to define what we mean by complementary and supplementary angles and then discuss how we can find them if at all possible. Okay, let's go and start by the definition of these two things here. We say that two positive angles, we'll say alpha and beta. You notice I give the two diagrams here. We say that they are complementary if and only if, first of all, they are both positive. Okay, so they both have to be positive angles. Right there. And we say that their sum is pi halves, or that is, they are 90 degrees, if you want to look at it as like a 90-degree case. So we say 90 degrees, which is the same thing as pi halves radians. So two angles that sum to pi halves and are both positive are complementary angles. So one thing I want to point out here is this. If you have two angles that are both positive and add up to 90 degrees in the first place, both of the angles must be acute angles, okay? And likewise, when we talk about supplementary angles over here, we say two positive angles that their sum is pi, or the same thing, as saying that is the same thing as their sum is 180 degrees. So long as they're both positive angles and they add up to 180 degrees, then we say that they are supplementary angles here, okay? So what I want to do down here on example, looks like number 2 here. It says, if possible, let's find the complement and the supplement of these angles. So you'll notice that we're given these two angles here and we want to find their complement and supplement. The idea that I want to kind of borrow upon is this. When you talk about complementary angles, let's say I give you some angle theta. How is it that we could find its complement? So just as a thought experiment, when we talk about this in degrees, maybe we say 40 degrees. If I had a 40-degree angle, what would be complementary to this? In general, what we could do is we could say, well, it is the angle that adds up with 40 degrees to be 90, okay? So we say, well, what angle would add up with 40 degrees to be 90? What we could really do is we could just say this. We could say we'll take that total 90 degrees and we'll subtract off the 40 degrees. Or in other words, in general, you see what I've written there, we'd say that you would just basically take the angle that you're given and take it away from 90, okay? In this case, we're talking about radians. So one thing I want to do is I want to kind of write up here, we say complementary angles. If you want to find complementary angles, we're basically going to say this. Given theta, its complement will be, and we'll say this, 90 degrees minus theta, or pi halves minus the original angle that we were given, okay? So that is how we're going to find the complement. Likewise, when we talk about the supplement of an angle, we say if I wanted to find, say, the supplement of angle A here, it's kind of like saying this. I know that alpha, the measure of angle alpha plus measure of angle beta has to add up to 180 degrees or pi. So if I wanted to say, well, what is the measure of beta here? We could just say, let's take 180 degrees and subtract off the original angle alpha. So we say, given some angle, we could say 40 degrees again. To find its supplement, all we would have to do is take 180 degrees and subtract off the original 40, or in general what we could say is take the original angle and subtract it from 180. So we say supplementary angles. What we could say about supplementary angles is essentially this. Given theta, its complement, so we say supplement will be 180 degrees minus theta, or we could say pi, which is the same thing as 180 minus the original angle theta here. Okay. So one thing I do want to kind of mention is this. If you have an angle that already exceeds 90 degrees or pi halves radians, let's say this was our angle right here, we would say that this angle is indeed positive. We call this angle theta. We could actually go ahead and find its supplement, or the amount of leftover you would need to carry you over to pi, or 180 degrees. But because the angle that we have to add to this in terms of the definition of supplementary, it says two positive angles. Will this also have a complement? Is there an angle that I could add on to this obtuse angle theta to get me back to 90 degrees or pi halves? And the thing is this, since you've already exceeded 90 degrees, then we typically say that this angle would have no complement if that's the case. So just keep this in mind. There does exist a negative angle that would rotate you back to pi halves, of course, but we say by definition we say that these are two positive angles that either sum to either pi halves or pi. So what we're going to say is we're going to say, if possible, let's find the complement and supplement of these angles here. We say pi sixth. If I wanted to find its complement, let's start with that. We'd say, well, then its complement would be equal to 90 degrees or pi halves minus the angle that we were given, so pi sixth. And in this case, we're going to need to find a common denominator. So it looks like we're going to need this. We're going to need 3 pi sixths, which is the same as pi halves, minus a single pi sixth. And what we get here is a 2 pi sixth radian measurement, or we can go ahead and reduce this since 2 and 6 share a common factor to pi thirds. Okay, so pi thirds radian measurement would be its complement. And you know what, if we were to just visualize this here, keep in mind pi sixth is about a 30-degree angle here. We say here's my pi sixth radian measurement. Then it would take 2 more pi sixths or a pi third to get me up to 90 degrees. And then likewise, we'll look at the supplement here. We say, well, the supplement of this angle would have to be equal to pi, or 180 degrees, minus the original angle that I was given, which was pi sixth. And in this case, we're going to have to find a common denominator again. So we say this would be 6 pi sixth minus a single pi sixth, and we get left with 5 of these pi sixth things. So this indeed does have a supplement. Okay. So now let's take a look at letter B. And again, you know, looking up here at the picture, we say another 5 pi sixth would get us over to pi radian measurement there. So they are supplementary. This angle here, let's go ahead and start with the sketch. 5 pi sixth. You know, you can imagine if we were to split this up into, you know, sixths of pi, and we say 5 pi sixth. 5 pi 6 would be this angle right here. So you'll notice that we're already starting with this obtuse angle here, this obtuse angle. Let me get that out of there. There we go. So this is our 5 pi 6. We say, well, what is its complement? One thing I want to show you is this. We could try to find it. As a matter of fact, it's not that bad to do. We say, let's take 90 degrees minus the original angle, or let's take pi halves minus the original angle. And we could say, well, then in terms of a common denominator, again, we get sixths. So we say 3 pi 6 minus 5 pi 6. This is going to give us negative 2 pi 6. So one thing I will say here is this, or we could say negative pi thirds. We would say that the complement does not exist. And the reason why is because by definition the complement needs to be a positive measurement. Okay, so let's talk about its supplement. Would its supplement exist? Supplementary angle. So we would say to find the supplementary angle, according to this, we take 180 degrees minus the original angle, or we take pi radians minus the original angle here, which was 5 pi sixths. So 5 pi sixths, and we get this. We get 6 pi sixths minus 5 pi sixths, and we get the remaining pi sixths. And you know what? This just shows up on our picture up here. We take 1 more pi sixth to get this 5 pi sixths over to 180. So that is how you find complementary and supplementary angles, especially using radian measurement. Cheers.